Okay, the last concept I want to talk about is gravity. All right. And I love to start talking about gravity when focusing on our own solar system. And hopefully, we know enough about our own solar system to understand these ideas that I'm going to refer to. Um, really quick, the largest object in our solar system is the sun. Um, Now, as far as this being, accurate to size, it's not. To give you an idea, it would take at least a million Earths to occupy the same amount of space the sun takes up. So we are a speck, a grain of sand in our own solar system. Something interesting of note. All the planets, not including moons, but all the planets that are actually made up of real solid matter, such as rock, substrate, uh, these are the closest planets to our sun. And NASA even found this to remain true, um, even looking at other solar systems. Gas giants always seem to be on the outer fringes, whereas the solid um, constructed planets were closer. And that really actually has a lot to do with its inertia, its gravitational pull. It also depends on what the substances are within these planets, like molten iron, or even iron at all. Um, and its magnetism as well, but I'm not going that far into it. But they're located closer to the star in its solar system. Whereas gas giants, such as Jupiter, Saturn, Uranus, and Neptune, are um, made up of gas. I mean, they still occupy space, so they do have a lot of mass. In this case, Jupiter has far more mass than Earth, but it's how that mass is used and constructed. And, we're more of a tight ball, where this, Jupiter is far more expansive. But it still has plenty of gas matter made up in it and is easily larger than Earth. And I'll get into this concept here in a second. But, we look here, these gas giants are, much larger than Earth itself. But they're pushed out to the outside, and that's because they're made of gas as opposed to solids. All right, so gravity, right? Here on Earth, we weigh ourselves, right? But what we're truly weighing is how gravity um, is interacting with our own mass. And yes, more mass, more gravity, more weight. There is that correlation that links together. Um, but, you know, let's say we were to take a field trip to the moon. The moon is roughly 1/3 the size of the Earth. So if you weigh 100 pounds on Earth, you weigh roughly 33 pounds on the moon. Does that mean you lost mass? No, no. It's because the moon produces less gravity, because the more mass something has, the more gravity it's able to produce. Also, going back up to what I was talking about, um, with our solar system, I mean, there's a reason why everything orbits the sun. It's the largest uh, uh, star in our solar system. It's the largest object in our solar system. So everything travels elliptically around the sun. And it's because it is filled with so much mass, it's able to generate more gravity. For example, the Earth orbits the sun, but the moon orbits the Earth while the Earth is orbiting the sun. Because the Earth has more mass than the moon. Therefore, the moon is kind of trapped in its gravitational pull, which forces it to orbit around the Earth. And the Earth is trapped by the sun's gravitational pull, so therefore we orbit it. Essentially, it's the bigger it is, the more mass it has, most of the time, the more gravity it produces. All right. So let's go back to that trip on the moon where, the moon's mass is 1/3 the size of that of the Earth. So essentially, we can lose 2/3 of our weight just by simply traveling to the moon. Does that mean we would look different? Absolutely not. We would have the same structure, the same amount of mass that we would have on Earth. It's just the gravitational pull of the moon is, 2/3 less than what we find here on Earth, therefore changing our weight. If you were to climb up to Mount Everest, you would actually be anywhere between 5 to 10 pounds lighter, not because of the work you put into it, but because the further you get up into our atmosphere, the less or the further you are away from the Earth's center, which is a molten iron core. Therefore, we would have less gravity acting on us. So therefore, we would weigh less, but we would still possess the same mass. So, next time you weigh yourself, really, it's really gravity that you're weighing, affecting your mass. All right, so let me kind of flip the switch here. To give you an idea, this is Jupiter. This is the equatorial storm that's found there. It's essentially a hurricane, and we can fit 100 Earths within this circle. So that gives you at least an idea of scope, how large Jupiter is. It is a gas giant, but if we were to figuratively step on to this planet, we would increase our weight tremendously, like at least 100 times more than what we do, because it has more mass. So more mass, it produces more gravity. Therefore, the way it affects our quote unquote weight on this planet. I mean, to be honest, if we could step onto Jupiter, the gravity that it's producing may actually crush us. It's because it's so large. And if you can imagine, if we could step foot on the sun, I mean, we could fit 1,000,000 Earths in there, and therefore the gravity that affects the sun would be 1,000,000 times more oppressive or impressive, depending on how you want to look at that. But the thing is, mass affects gravity. The more mass, the more gravity, the more weight. And gravity is a very, very, very important force. Really, the two forces that you need to know outside of a push and a pull are gravity and friction, and they work together. Or against us, depending on what you're trying to achieve. Think about riding a bike up a hill as opposed to going down the hill. Going up the hill, you have gravity and friction working against you. Going down the hill, you have gravity working with you and friction trying to stop you, but gravity will ultimately win out there, because think about how bikes are designed. But I mean, really, it comes down to the more mass, the more gravity, the more inertia something has, therefore the more weight it has. All right. So I hope you enjoy that, and I'm sure you can hear my kids in the background. You guys take care.